Welcome to this short demonstration video for the OneBenthic Faunal Change Tool. And this app is designed to look for changes in macrofaunal composition between one or more baseline surveys and one or more monitoring surveys. And it can be used for monitoring licensed areas or marine protected areas or R&D sites. And the data used in this app come from OneBenthic, but we're also using spatial data. And if we look at some aggregate dredging sites, for example, these spatial polygons are used to assign samples to different treatment groups, which are then used in the analysis. So the way the app works is you first have to select a sector. So I'm going to choose Ag for aggregate dredging. You then need to select one or more baseline surveys and one or more monitoring surveys. If you didn't know the names of the surveys which you've got to play with, then you can use the map tool to find that out. So I'm interested in the Anglian dredging region here, so I'll just zoom in on that. That's this block of licenses here. And you can turn on all the samples that have been collected in the region by checking that box. And then if I just draw a box around that, and look at the search tab, this will bring up a table with all the samples that have been collected within that blue box. And the main thing to look at here is the survey name, and there's also a column for date as well. And just to show you a few examples, we've got data from the Anglian Maria survey and the Anglian REC or Region Environmental Characterization Survey, and you, as I say, you've got the dates there, so you can work out which surveys you want to compare. So in this case, I happen to know which surveys I want to look at, so I can just start typing the names in. So as soon as you start typing, all the surveys with the word or the letters that you've just typed in will appear. So I'm interested in 3 surveys for the baseline. So it's the Anglian REC, the Anglian Maria, and the Anglian RSMP baseline. So the baseline is made up of those 3 surveys, and then the monitoring survey, the latest one for the Anglian region RSMP was 2018. I then need to select an RSMP array, so this is the Anglian, and you can see in the map here that all the samples for the baseline are shown as blue, and all the samples from the monitoring are shown as turquoise. And you can see there are stations where you've got both a sample from the baseline and the sample from monitoring, and you've got stations where you've only got one or other, either a baseline or a monitoring sample. So you can choose to use all of the data here, or you can just choose the paired stations, and I'm just going to use the paired stations in this example. Okay, having done that, if we now go over to the tabs here and look at the data tab to begin with, you've got four different tabs underneath data. So you've got a table for all your baseline samples, a table for all your monitoring samples. In this tab, joins them together. So these are all the paired sites. And then in the final tab, your samples are assigned to different treatment categories. And that information is present in these final columns in this table, and that assigning to treatment is based on those polygons which you can see here. Okay, so if we now move to the results tab, you can look at the results at a variety of different spatial scales. I'm going to look at the region here because that's most appropriate for the data we're looking at. So all of these samples fall outside the footprint of aggregate dredging in the reference area. And there are a number of outputs here. So we're looking at univariate metrics for richness and abundance. And we're also going to look at the data in a multivariate sense as well. But starting off with the univariate outputs, so we've got some box and whisker plots here, which allow you to compare median values between baseline and monitoring. And then the next tab shows the means. So you've got a mean value of richness at the baseline versus the monitoring, and again for abundance. And you've also got the standard deviations there. And then we apply a statistical test, so it's an analysis of variance. And what this shows is that we've got no evidence of any change in richness, but we have got evidence that we've seen a change in abundance. So you've got a statistically significant difference there. And if we just go back to the box plots, you can see that quite a lot of the samples were a bit higher than they were in the baseline. And so, yeah, it appears that on average, your abundance has gone up. We've also got some multivariate outputs. So starting off here with a non-metric multi-dimensional scaling ordination plot. So each of the dots here represent samples, and their position in this ordination is based on their macrofaunal composition. So samples that are close together in this plot have got a similar composition in terms of species and counts. Ones that are far apart are quite dissimilar. It's worth just drawing attention to the stress value here. So this is quite a high stress value, which means this ordination isn't a particularly good representation of the dissimilarity and similarity between samples, but we can get something from it. I think you can see here it does appear to be some separation of samples, but there's a fair bit of overlap as well. We then carry out an ANASIM test. That will just take a minute to run. And what this shows is we've got a p-value here of less than 0.05. So that means that we have found a statistically significant difference between baseline and monitoring. But we have to think about effect size, and that's what the R value is telling us, and that's quite small. So you have to sort of, when it comes to interpreting the ANASIM result, you need to look at both these values together. And in this case, the interpretation is that the baseline and monitoring are similar, but with some differences, or there's a high degree of overlap. And then finally, in the SIMPA tab, this is Similarity Percentages analysis. This will give us some idea of the species which are driving or responsible for the difference between surveys. You just have to be a little bit patient. What this shows is that the species that's most responsible for the difference here is Sabularia, and you can see that your numbers here have really gone up between the baseline and the monitoring survey. So that's it. Hope that's been helpful. Thanks very much.